Hi. The idea of this presentation is to show you the demo that was delivered to one of our prospects in Mexico, IMB. They had several primary objectives. First of all, to take the data from PDS and load it to AB, including the class hierarchies, attributes, apparently all the components from multiple disciplines like equipment, piping. Well, they wanted to see structural data and cable trays and HVAC, but due to the time limitations, we limited it to only equipment, instrumentation, and piping. The second objective was to make sure that when we bring the data in, we can actually see all the coding relationships between tags, for example, like the relationships between line segments and components and other tag hierarchies. And the third objective was to manually create several documents and just associate them to some of the tags, only to show the concept, because the only input data that we received from them was the iModel. Well, we received the PDS database, and then our Bentley colleagues just used PDX Manager, or whatever it is called right now, to extract the data from the PDS database and produce an iModel. So the only input data that I had was the iModel itself. And the last but not least is that this should be delivered as the whole all of those functionalities that we just discussed should be delivered via a web portal, including the capability to actually go into the iModel, review the graphics, and compare it with the representation in the asset management portal, and so on. So let's proceed, and let's start with an overview of the dataset. And we have just a few reports here, so I will quickly walk you through the reports, and then we will look into the iModels. So as I said, we had multiple disciplines here, not a lot, and that's a tag summary report that is supposed to break down the tags to disciplines, but that's just my decision because the customer didn't provide any expectations, any requirements, so it was completely my imagination. And I decided to break it into like equipment, piping segments, pipelines, valves, and everything, well, all the rest. And surely, well, you can see that the total amount of tags was something about 9,000, which is not too much, but still quite a few tags. And for example, we only have 14 equipment tags, which is not a lot at all. And surely you can, so that's an SSRS report, but and with the drill down, and you can then navigate to the particular tag if you like. So clicking on the tag number will actually open the page with the attributes and the relationships to other tags, documents, whatever, you name it. So I'm not sure whether it makes a lot of sense to go through, oops, sorry, the same one. Whether it makes sense to go through all of the disciplines, but just to give you the idea. So if we go to valves, for example, we will see all the classes of valves that exist in the dataset. And again, we could navigate to the particular tags. So that's the overview of the, and we only have several documents and tags in this dataset. So we could go further and we could proceed with creating physical items, for example, because I do think we have some, though not a lot of information about equipment models. But just to emphasize that, well, I think we had about 2 weeks for this exercise in total. So we didn't want to go into a very deep level, just because we were very constrained by this. Okay, the next report that I would like to focus on is the completeness report. And again, as probably usual, We didn't receive any requirements from the customer, and I even specifically tried to ask them whether they need anything like that, whether they need any validation or well anything. And they said no, that's fine. We have all the data in PDS and it's just clean, consistent, correct. We don't need anything. But still, as a team, we decided that probably it makes sense to show them at least some of the capabilities and well different capabilities if possible. So in this dataset, I've configured first of all the tagging scheme validation for piping segments. So you can see, by the way, the segments. Well, those are the piping segments, so you can see how the tag is built. So we have the validation of this configured in DQS or EB data quality servers, so lifecycle server uh, lifecycle server, whatever we want to call it. And we also have this SSRS report exposed in EB to show the how many of the attributes, the mandatory attributes, were populated for all of the tags separately and in general for all process lines. And just to give you the idea why we have this, well, the total amount of attributes is 10 is if we go to director and, well, you all know that we have the mandatory field in for our attributes. So I just marked several of them as mandatory. And that was my decision, so it's quite a random one. I just looked at the data and I wanted to expose some of the attributes that do not have data populated as mandatory as well, just so that we do not have all the lines with 100% of data. So I think in this example, and we will see that we have the hydrostatic requirements and I think stress requirements that were marked as mandatory, and none of the pipes, well, pipe segments basically, have this data populated in PDS in that particular case. And also just to show you the well, not none, because you can see that I've added this visual like highlighting to show all the tags that have more than 80% attributes populated. And if we go to any of those, you will see actually, if we go to history, you will see why they have this data populated. It's just because I manually entered some of the values for those particular attributes. And just to show you that that interface, that report is dynamic, so we could, for example, go here and say that, okay, no, I don't think that we need a unit number as the mandatory. And if we go back and click on refresh, then hopefully after a few seconds, as usual, hopefully we'll see a different picture. So now we have the amount of attributes that are required is 9, and we have the different number of attributes populated. Okay, that was it for the completeness report. The next one that I typically prefer to show something like that to the customer is well, equipment list or line list or whatever, just to demonstrate that we can configure, well, basically any parameters, any search parameters that they want to see, or any columns in the output result set. And we could also, like, okay, in this case, I do want to, for example, search for all the piping segments that have the nominal diameter of 2 and the fluid code of BW. And if we run the report, we should get some results. And it's probably, it also makes sense to emphasize that we can use the functionality to download all results to Excel. So that's some of the data that they have in the system. The last but not least, what we demoed to them is that they could use the standard search capabilities, so they don't have to configure reports. And that we have the quick and advanced options, and the advanced options will provide some default parameters, but they could redefine that as well. And so in this case, for example, I configured a very simple alternative tag search and called it just IMP tags. And I know that, for example, there are some components that have the unit number of 10. So, okay, we could quickly search for those components. Or we could use that approval status is actually not the EB approval status. That's one of the attributes coming from PDS. And so on. So we could continue here if we like. So that's all about like the overview, searching, reporting. And the next way of actually, well, getting access to some of the information in EB is browsing. So we could browse for documents, for example. And in this case, I'm using the auto-filling folders. So, and the only criteria that I've used was the class of the document. So I think the folder names are quite self-explanatory. So if we go to any of those documents, we will see some of the relationships to tags. Well, not for all of them, but for those. Again, that wasn't a manual exercise. So for those documents that I've created relationships, we would see them. And we could again navigate to the particular tag and see its properties, relationships, and so on and so forth. The thing to emphasize here is that we could also use named relationships. So you will see that for the iModel, so all of the tags are related to the iModel because that was, well, and the relationship is called just document, and that was the default relationship that was created during the loading process, loading exercise that was done through the DQS route, EB Data Quality Service. And the rest, for the rest of the documents, I created some of the named relationships. Like, okay, in this case, we have the relationship to a structural drawing and the vendor drawing. And if we go to the vendor drawing itself, then we would see that it's not only the relationship to a tag, but that's the equipment tag, and so on. And talking about named relationships, it probably makes sense to also, well, if we're looking at the particular equipment tag in this case, we can also see that it's related to some of the line segments. And again, and that's the next part of the next objective that they wanted to see. So we've brought in and let me just quickly go to the directory again, because if you remember, the first objective that I named was to bring in the PDS data, including all the class hierarchies and attributes. So I kind of showed you the attributes here, but just probably makes sense to show the classes as well. So you will see the same classes when we are actually looking at the iModel data. So all of those classes were brought in as the part of the loading process through DQS. So they were extracted automatically from the iModel. So the next objective was to show the attribute data and tag relationships. And the next one was to show the relationships to documents. So we've kind of looked at most of it, and now let's just probably focus on, well, first of all, looking at the attribute data itself, and then comparing the data in EB and the data in the iModel, just to make sure that they are consistent. And to do that, let's grab a tag and let's go to the document. So I will open the iModel. And for this, for this particular exercise, I will open it in Navigator. But as I've mentioned, we could actually use our, let's say, built-in viewer. So we do have the DGN ActiveX plugin, or DGN ActiveX control, that allows us to review the iModels in the web portal. However, I would not recommend to use it. Well, it is not officially supported by BSW, so it only has a limited support for demos. for demo purposes. And I also found out that it works quite okay on Internet Explorer 8, but for me, Internet Explorer 9, which I have on this machine, it wasn't very reliable. So when you perform some operations, it can just crash or whatever. So whenever possible, it's probably a good advice to just try to use Navigator. And then, okay, if the customer does want to see the viewing in web, then we can show that as well. And we'll do that. So the Navigator, I don't have to describe you the interface itself. And the reason we have this, well, we actually had two files, was that I manually added let's actually close the document itself. We had two files, is that I manually added the overlay file just to show the idea of the review process. So because in Navigator we could create markups and navigate to the markups and so on and so forth. But so far our built-in viewer, the web viewer, does not support markup capabilities, and Navigator is also not integrated with AB. So to create those markups so that they're seen, you have to do some manual work in AB Director. You have to create a relationship between those two files. But that's again just for your information. So if we start looking at the particular data, let's say that we want to find this line segment, and we will just go to, well, there is no capability currently in AB to just click on the document and so that it opens and we dynamically zoom to this component. So that's something that will be delivered with the visual navigation project that has just started, I believe. So before we have this, we need to open the document and we need to explicitly search for the same tag that we look at in AB, for example. And in this case, I will use the system unique number, that's a PDS attribute, to search for this piping segment. Well, the funny stuff about this is that though it is called system unique number, it's not actually unique. And I believe we will see that in this example as well. So that's why I had to use not just, well, I had to combine, for example, in this case for piping segments, the line number label, which is a human readable name, which people want to see. I had to combine it with system unique number to get actually the ID of the tag that would be unique. Because in this data set, they may have multiple segments with this line number label. Sorry. And they might have multiple components with the same system unique number. So it didn't work much as is. So we can look for example, items by common properties. And if we don't know, well, in this case, I know that I'm looking for a piping segment. But if I didn't know that, I just had the system unique number, I could say that I want to select all the classes and then just specify that, okay, I have the particular attribute and it should be equal to, oh, no, I didn't copy it, apparently, and it should be equal to that. And after a few seconds, I do believe that searching is working faster in EB Web, by the way. Well, in this DGN ActiveX control, I'm not sure why. Let's close this, I guess. So you can see that we actually have two components in this iModel with this system unique number. But one of them is the component that we are actually looking at. So it is the line segment. And let me just do this so that it's easier for us to probably compare. the data. So let's first look at the at the attributes. So if we select the object in Navigator, we would see the details of this particular component, and we can also see hopefully the same information, the same set of attributes in EBWeb. And if you use, by default, why is it not doing this? So by default, EBWeb will reorder all the attributes just alphabetically. But in layout editor, you could modify that and you could specify the order that you like. So that's what I've done for the piping segments particularly. And just to show them that, okay, if you want to see all the attributes in the same sequence, you could do that as well. So we could start comparing the data, and as you know, EBWeb will not, by default, EBWeb will not expose the attributes that are blank, that are not populated. So you will see some of the difference, like, okay, we do not see the module number or the package system number, and that's because we don't have data in those fields. But the rest should be more or less the same. So if you start looking at the we have the fluid codes, and we have line sequence numbers, we have piping diameters, piping material class, gasket separation, and so on. So believe me, it's more or less the same data. I've done quite a lot of tests, and for different types of components, we had some issues, and I will quickly focus on them, I guess, a bit later when we talk about just in a few words, when we talk about the loading process itself. And you will see some differences, for example, in this case, that the PNID index number is equals 0 in the iModel, but it's 1 in EBWeb. But you can also see that it has been changed quite recently. And if we hover over the mouse, we will see that, okay, it was changed probably 2 days before. And I just did it to show them this concept of audit trail. So if we go to history, we will see that, okay, those are the attributes that I changed. And I can see that in that interface as well. Oh, that was wrong. I shouldn't have done that. Sorry for that. Okay, and now let's look at the relationships to other tags. So once we're fine with the attributes, we can start looking at relationships. And if we look at this particular segment, in the iModel, so in PDS, it has 4 relationships to a line and to 3 different components. Well, here we have 5 relationships, and to be honest, the relationship to the equipment I just created manually because, it wasn't exposed explicitly, and at the later stage I actually found out that we do have the field called nozzle ID, so I assume that we could actually extract this information automatically. But I found out this quite late during this exercise. And again, that's only proof of concept with limited timing, and that wasn't a complete implementation. So we could extract it automatically, I'm quite sure. But here you see that there is no relationship, no relationship to equipment. There is only PDS attribute. So, but if we look at the other relationships, you will see that, okay, there should be a relationship to a flange, a tubular component, which is basically just a pipe and an elbow. And you will see the same components here, hopefully. The only difference is how they are named, but that is completely definable. So you can actually say what you want to see in EBWeb. In this case, I wanted to see the class of the object that basically corresponds to what we see on the right in the iModel, so in PDS. And I also added the system unique number to it. The reason for that is just because if there are multiple components of the same type, it's easier to differentiate between them without having to click on the particular object. So just to give you the idea, if we go further to the lines, to the pipeline, and we do the same here. So we should actually see quite a few segments. And here they are. So it looks quite okay. I don't think I can resize it. So we see the segments, but again, I decided for this exercise that I want to create another relationship, a relationship from a tag, from the component of the segment to the line itself. So this relationship is not explicitly well defined here, but you can always deduct it. And I just wanted to have this information to like enrich the model, but we don't have to do that. And if we go to, well, I see that I used probably this segment yesterday. So I think it's something like, let me just quickly see. We had yeah, that's probably the segment that have several components. Because it's boring to show the example with just a few components, so let's just grab the one that has more. And again, if we look at the particular component, and we can see that that's the same one because we are looking, we see the system unique number in PDS or in iModel, sorry, and that's the same system unique number here. And you will see that, okay, we are supposed to have relationships to different, to three different pipes and to two elbows. So what is great about Navigator or the web viewer is that you can then say that, okay, I want to see actually where those components are located. And you could see them in the context of the model. So that's something that we don't see in EB directly, but we could use our built-in, let's say, this DGN ActiveX control. So let me quickly try to show you that, and I will go to my laptop because I was working from the virtual machine so far, from the server side, but I'm not happy with Internet Explorer 9, so I'll go to my laptop where I have 8. And if we just click on the file, on the iModel, it should pop up with this ActiveX control, and I'm not quite sure what exactly the timing, so the time to actually load the model depends on, because I found out that it can vary very significantly from like 5 to 10 seconds to probably 1.5 minutes. And it's the same model, it's the same server, the same configuration, so not sure. It's not very fast, but it's quite okay. And you can also see all the item hierarchies here, so all the classes, and those are the same classes that we saw in EB Director when we were looking at the class hierarchy. And here you can say that I want to search for example, this particular component, or I want to look where it's located. And it's the same kind of capabilities that we have in Navigator. So you could highlight, zoom, isolate, then you could do some rotating, panning, and so on and so forth. So if we look at something more interesting, let's probably try to look at at some pipeline, and you can see it's not very fast. But let's just expand some of the components and navigate to them. So it still works quite nicely, I think, because yeah, it's just EB Web, and we can have this navigation without the without the particular tool installed like Navigator or MicroStation. Yes, it does take some time, but still it's quite nice. And you can also do the searching here as well. I'm not sure. I think the performance issue now is also because I'm recording this session, because I was doing that before, and believe me, it works much better than it works now. But I think I should be still capable of showing you the advanced search capabilities, and you will see that it's the same dialog that we saw in Navigator. So we could say that we want to search for components, and again say that we want to search for all the classes. And I will just do the same. Or you know what? We could search for a valve, I guess. Let's do the following. I know that the valves are called. Well, there is the instrument component number property, and if we say something like this. So I want to search for, that's the search that I used in EB Web before. So I want to search for all components that start with, sorry, PSV. And if we add this to the search and execute it, then yeah, we get the same result. So we have the two components that we saw previously. And I think that's about it. So that's, which one is, yeah, that's the correct one. So that's about the data set that is represented in the PDS data set represented in EB Web. I believe I showed you at least most of the stuff, so I don't think we need it anymore. And just a few words about the loading process itself. So to do that, we used Lifecycle Server. And that's a separate server application, and that was the reason to use Oracle database, because as far as I know, we currently do not support SQL, well, with the latest version at least. And I've been told by the gurus that, well, we kind of support SQL Server still, but the performance issues are huge. So it's much better to use Oracle if you want to run LCS. And again, it will take a couple of seconds, just as usual. And here, well, I don't think I need to make some. I'm not an expert in Lifecycle Server by any means, so I'm not going to, well, to show you some very funky stuff or give you an introductory training to what Lifecycle Server is. But just in a few words, for those who might not know that, if those people are watching this recording, we can configure some so-called data stream templates, which are representing the series of tasks that should be done. And each of those tasks can either, for example, export the data from some, import the data from some external source. And by that external source, we could mean, I don't know, a TXT file, a CSV, so comma separated, tab separated file, XML or Access or SQL or Oracle database, and so on and so forth. One of the possible sources is also iModel, and that's what that's what we've done in this case, and I will show you that in a few seconds. So the other types of tasks can be different conversions. So for example, when we extracted the data, we want to adjust it somehow, or to add some richness to the data model, or we want to apply some validation stuff, or when we want to produce an error report. And the other, well, the obvious type of the task would be to actually import this data to EB. Okay, so let's look at one of the data stream templates, and we have the one called iModels to EB inside. Well, that's the way I decided to name it. And we have just one data set here, and well, all the steps are completed, and I will not run them again. You can see the timestamps here. So for most of the steps, like extracting the XML from the iModels and then processing this XML, it actually took just a few minutes, but the loading process, the last step, as you can see, took more than 7 hours. But during those 7 hours, we created, as you might remember, 9,200 tags. So it's probably not that bad. I believe it's something like 3 tags, 3 seconds for a tag. But still, it's not only the tags, it's all the attributes, all the relationships, and you only do this once. Because if you do the update, it will take less time. So just a quick overview of the steps. Okay, so we extract the information from the iModels, and that's the first task, and you can see that for all the tasks we have this type, what type it is. And we need to provide some attributes, but well, in this case, not just a few of them. Like if I decided for this exercise to just filter out nozzles and ports. Those are PDS classes. So if you do want to see all the complete PDS model, then this filtering will be blank. If you do want to say that, okay, I only need valves and I only need equipment and probably lines, and that's it, then you would continue filtering and just provide the names of those classes that you do not want to see in AB. And that's just the the location of the iModel file. So this task, when it finishes processing, will just produce an XML. And I could show you the XML if, well, I'm not sure whether we need to go into that level of details. I don't think so. So, okay, let me just quickly show you some of it. So it will produce something like this. The problem with this is that, for example, if we look at this XML, if we look at the first tag that we have here, which is the pipeline, and you will see that it has, for example, an attribute called alternate design pressure units. And the value of this is 20, which doesn't make a lot of sense, because it's just the numeric code, and there is a lookup table in PDS that is used to actually expose the correct character value. So that was the reason why we have the next step. So if you look here, the second step is process PDS supplemental lists. And that is a task of the type XML conversion. So what it does, it takes as the input XML file, you will see that there is a file shortcut which is pointing to the previous to the output of the previous task, and that is actually doing the following. So that's the conversion that is applied. That's the XSL conversion. And for example, for alternative design pressure units, it's actually looking and replacing the value in this node, in the node with this name, with information taken from this file, PDS supplemental lists, blah, 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 and in this particular node in this file. So if we look at the mapping file, that's the PDS supplemental lists. That's what you will see, that we have, well, that's the example of the fluid code, but we could use all of the attributes, we could review them. So that's how it works. It actually goes here and takes the numeric value and then replaces it with the according value that should be displayed, the meaningful one, the human readable one. And the result would be something like this. So I will not process it, I will just show you the result. And due to the fact I'm not an expert in XML by any means. So when I produced this XML, I had some issues with formatting. So now it's formatted to just one string, and that's the reason it takes that long, because it's quite a big file. But just to quickly show you that, I think we should be able to do that. Almost there. Yay, we've done that. So what it will do, it will actually replace those nodes and well, with something more meaningful. Okay, that was the second step. And the third step is pre-processing this XML with all the lookups substituted. And by pre-processing, we just prepare it for, well, that's the first step of preparation to be loaded to EB later. And well, we can look quickly at the conversion XSL for this step. So that's where we need to decide what exactly we're going to use for the object IDs or the object names. And you can see that in this case, well, we have some mapping that, okay, if we have an instrument, then we're going to use instrument component number as the object ID field. If we have, for example, a piping segment, then we're going to concatenate the line number label with the system unique number. If we have a piping support, then we take the pipe support number and the system unique number, and so on. And we have a different, well, a bit different, you will see a bit different mapping for object names. Because, for example, for most of the classes, I'm using the class name, so the class itself, and system unique number as the component name. And that's what we've seen in AB Web, and that's what I think I mentioned before. The next step is converting this to FMXML. Well, FM stands for Facility Manager, and that's the format that can be directly imported to EB. And during that process, there is, well, that's probably the most complicated one, because here, well, I will just scroll down to the part that most of it you can just leave as is. I will just scroll down to the part that I had to look at and I had to modify, because here it actually, well, it actually describes all the relationships that you have in the model. So, for example, in this case, we had a relationship called segment has component. That's the relationship coming from PDS, and we need to explain to EB how to treat, well, to DQS, how to actually treat this relationship. And well, in this case, I'm treating those as two actual relationships. I'm creating a relationship called connected to for the component and the line segment, but I'm also creating an explicit relationship to the line itself, so to the parent line. And you've also seen that in EB, I believe. So that's about it. The last step is loading to EB, and the only attributes that we need. So there is no XSL, for example. There's just an input file, which is a link to the previous step. And the attributes that we need to provide is just the data source name and the admin and login, well, the user login and password. We could apply some validation here as well, and well, because they didn't have any particular requirements, so I just added a separate step validation, even a separate data stream template, just to show them the concept, and they never asked about it, and we didn't have time actually to cover it, but just for you, okay, we can do that. And in this case, well, we do have some issues, and the validation, there is a separate type of task which is called validated tags, and I will just show you the scheme that I configured for this validation. So we do have a separate tool called Validation Manager, and if we go and see what definitions we have here and look at the segment one, for example, That's what we are validating against. So we're saying that every piping segment should consist, well, the tag should consist of those 6 parts. So first we have the diameter, then the fluid code, the sequence, material class, suffix, and system unique number. And here you specify the length of each of those parts, what delimiters we use between those parts, whether they have fixed lengths or it can be variable length, and and the type of the data. So, well, just to, as a quick overview, probably it would be nice if I had the particular tag. Let me just quickly go here. I need any document, any tag. Let's start with something like this. So if we take this pipe segment ID and then try to check whether the identifier passes, okay, it passed because it complies with this particular pattern. But if we do something like this, I will just, that's the 4th component, which is material class, and I can see that it should have the fixed length of 3. And if I add the 4th one, then okay, it will fail, and it will tell us why it failed. Well, it actually tells us here in the XML. It will not. It will just say that the tag didn't pass. So if we look at the result of this step, for example, and if we go to, let's save it to somewhere. Oh, I think we already have it. And then probably I've already copied it to my machine. Yes, I did. So if we look at those, for example, you will see that, okay, the only error message that it produces is that it didn't find the format, supplied format. And that's exactly the issue that we have here, is because the piping material class has 4 characters instead of 3. And I think now that's it. So that's quickly on the both how we brought in the data and how we processed the data and what we received at the end of the day. Thank you. I hope if you didn't enjoy it, at least it could be something useful. And yeah, good luck.